All right, so last week, Thursday night, the 13th of March, 2025,
Mm-hmm.
something pretty incredible happened up in the sky.
Right.
A total lunar eclipse
Yeah.
visible all across the U.S.
That's right.
Now, you might have seen some reports maybe mentioning a slightly different date, like the 14th,
Right.
and that's probably because of time zones.
Mm-hmm.
Our main source for this deep dive, an online article titled "A Total Lunar Eclipse Made Its Way Across the U.S. Thursday Night,"
Yeah.
may have been published when it was already Friday in other parts of the world.
Right. Right.
But for us here, the main event went down on that Thursday night,
Yeah.
and that's what we are diving into today. We're
Absolutely.
going to explore what went down, where you could have seen it, and the science behind that really cool reddish hue.
Absolutely. Yeah.
Yeah.
Think of this as like your all-access pass to understanding this particular lunar eclipse.
Okay.
We're taking this news report and breaking it down.
Yeah.
Not just the what, but the how and the why behind the whole thing.
Yep.
Really gives you a chance to connect with this amazing natural phenomenon.
Okay, so let's jump right in. So the article is very clear.
Yeah.
A total lunar eclipse visible across the entire United States.
The whole thing. Yeah.
Coast to coast. And it wasn't just like a blink and you'll miss it kind of thing.
No,
Earth's shadow covered the moon for like a whole hour.
it did.
And during that time, it turned this, the report mentions this captivating reddish color.
Absolutely. Yeah. And the timing on these things is actually really precise.
Yeah.
It started, the eclipse, around midnight Eastern time.
Oh, wow.
So if you were up late on the East Coast, you would started to see that darkening,
Oh, cool.
that creeping shadow over the moon's surface.
I see.
The peak, when the moon was fully in the Earth's shadow, what we call totality,
Yeah.
that happened around 2:26 a.m. Eastern time.
Okay.
But it wasn't, just a sudden thing.
Yeah.
The whole process from that initial shadow to the moon coming back out, that lasted until about 6 a.m. Eastern time.
Wow, 6 hours.
Yeah, good chunk of the night skies show there.
That's a pretty big commitment to be a sky watcher.
It is.
So it wasn't just the U.S. that got to see this, right?
Oh, no.
The article mentions a much wider visibility.
Yeah, it's pretty amazing the geographic reach of this event.
Yeah.
The report points out that most of North and South America could see it.
Wow.
I mean, think about how massive that area is.
That's huge.
But it went even further than that.
Really?
Western parts of Africa and Europe also had a view, and so did parts of Eastern Australia and even Northern Japan.
Oh, wow.
It really shows you how these kinds of events, they connect different parts of the world,
Yeah, like a global viewing party.
Exactly, yeah.
The article actually gives us some really cool visuals from different spots.
Okay.
There's one over central Wisconsin on Friday, probably taken as the eclipse was ending.
Okay.
And then there are these awesome shots from Savannah, Georgia, taken between 1 and 4 a.m. Friday.
Yeah.
You can literally see the moon being swallowed by the shadow and then coming back.
Yeah, those time-lapse style photos, they're great for showing how dynamic an eclipse is.
I know.
You really see that Earth's shadow moving.
That's so cool.
And then you have those shots that mix nature with our cities.
Oh, right.
Like that one with the moon between the skyscrapers in Chicago.
Yeah, I saw that.
Taken on Friday as well. Reminds you that these cosmic events, they're happening whether we're down here a little up or not.
Totally.
Yeah.
Totally.
Yeah.
And it wasn't just the total eclipse either.
No.
We had some reports of a partial lunar eclipse over Lake George near Canberra, Australia. So they didn't get the full blood moon, but they still saw a good chunk of the shadow.
Yeah.
London, too. Above Canary Wharf, they reported a partial eclipse.
Interesting.
It shows you that even if you weren't in the perfect spot for the total eclipse, you could still see something.
Yeah.
There's also that photo from the border of El Paso, Texas, and Juarez, Mexico.
Oh, cool.
Really an international moment.
Yeah, those different images really bring home the point that this wasn't just one single event.
Yeah.
They have a whole range of experiences depending on where you were on Earth.
Right.
How much of the eclipse you saw, the timing, even how clear the sky was, all played a part.
Totally.
It was a shared event, but everyone saw it a little differently.
Okay, so let's talk about that blood moon look.
Yes.
The article says during totality, the moon turned this red color.
Right.
That's how it gets that blood moon nickname.
Yeah.
But it's not like magic, right?
No.
There's some science behind it.
It's all about how sunlight plays with Earth's atmosphere.
Okay.
It's really fascinating.
Yeah.
The article explains that as sunlight travels through our atmosphere, the blue light, which has shorter wavelengths,
Right.
it scatters.
Okay.
That's why on a clear day, the sky looks blue.
Oh, right.
It's that scattered blue light we're seeing.
So the Earth's atmosphere is like a filter blocking the blue.
Exactly.
Okay.
But what about the other colors? Well, those longer wavelengths, like red and orange,
Right.
they don't scatter as much.
I see.
So when the Earth's right between the sun and the moon, during a total lunar eclipse, sunlight can still reach the moon.
Oh, wow.
But it's mostly the red light that makes it through our atmosphere.
Mm-hmm.
And here's the cool part. It bends around the edges of the Earth and onto the moon.
So, like, the Earth's atmosphere is a giant lens shining red light on the moon.
That's a great way to put it.
Cool.
It's like the Earth casts a red glow.
Wow.
And it's the same thing that happens during a sunset.
Really?
Yeah, when the sun's low, its light has to go through more of our atmosphere.
Okay.
So more blue and green light gets scattered, leaving mostly red and orange for us to see.
It's amazing how those two things, a sunset and a blood moon, are connected.
Right.
Same science behind them.
Exactly.
It really shows how everything in nature is kind of linked.
It does. It shows how our atmosphere, this thin layer around Earth, really shapes how we see space. It's not just there. It interacts with light in these amazing ways.
Totally.
Yeah.
Now, if you were worried about looking at the blood moon directly, the article says it's totally safe.
Oh, yeah.
Unlike a solar eclipse,
Right.
you don't need any special glasses or anything.
It's a key difference. With a solar eclipse, you're looking at the sun,
Right.
which is super bright, even just a part of it.
Yeah.
But with a lunar eclipse, the moon isn't making its own light.
Right.
It's just reflecting sunlight that's already been filtered and dimmed by our atmosphere.
Okay, so it's safe to just look up and enjoy it.
Exactly.
No need to worry about your eyes.
Nope.
The article does say, though, that even though you don't need anything special to look at,
right.
binoculars or a telescope can make it even better.
Absolutely.
They can help you see more detail, even the different shades of red on the moon.
Yeah, even a simple pair of binoculars can really improve your view.
Wow.
You'll be able to see craters, the Maria, those darker areas. And as the moon moves into and out of totality, you can see those details even better.
That's awesome.
Yeah.
Now, for those who missed this one, or for those who are already excited for the next one, the article talks about some future eclipses.
Oh, cool.
The next total lunar eclipse is September 7th.
Okay.
And then another one on March 3rd, 2026.
Wow, cool.
So total lunar eclipses might feel rare,
Yeah,
but they happen somewhat regularly.
they do.
The article says they can happen up to 3 times a year.
Wow.
But whether you can see one depends on where you are and how the Earth, moon, and sun are lined up at the time.
It all comes down to where those celestial bodies are.
Right, totally.
Yeah.
And the article also says that the last total lunar eclipse in 2024 was earlier in the year.
Interesting.
So it seems like we're in a time when these total eclipses are happening a bit more often.
That's pretty neat.
Yeah.
While those partial lunar eclipses happen more overall,
Right.
it's the total ones, those blood moon ones, that really grab our attention.
Yeah, they make us look up at the sky.
Exactly.
Okay, let's sum it all up. So from our look at this report, we know that Thursday night, March 13th, 2025, a total lunar eclipse happened across the United States.
Yeah.
The moon turned red for about an hour as the Earth's shadow covered it. And it wasn't just us. People in parts of North and South America, Africa, Europe, Australia, and Japan could see it too.
That's right.
That blood moon effect is from sunlight passing through and bending around Earth's atmosphere, which lets the red light reach the moon.
Yeah, and a big difference from solar eclipses. It's totally safe to watch lunar eclipses.
You got it.
No special glasses needed.
And for those who missed this one, the next one's September 7th.
Yeah, and this event, as cool as it was, really shows how far we've come with science.
In what way?
For so long, people have been watching these things in the sky.
Yeah.
But now we can understand them and predict them really accurately.
Yeah.
Which shows how much we've learned about space.
That's a great point. So we've got these lunar eclipses, which we can predict.
Right.
And the blood moon effect, which we can explain with science.
Exactly.
It makes you wonder, what other things in nature, things that might seem mysterious now, might also have explanations waiting for us to discover? What mysteries will science help us solve in the future?
Right.
Like how we understand the moon turning red during an eclipse.
It's really something to think about.
Yeah.
Makes you look at the night sky a little differently.
Totally.
Especially when you're waiting for that next total lunar eclipse.
Yeah, I know.
It's exciting to think about.
It is.
What else is out there waiting to be discovered?
Absolutely.